What's up, guys? This is John back with another episode of Engineering Awesome. As you guys can tell, I'm still struggling to get content out. The biggest reason is because of all the design projects that I'm working on the side. So, in an effort to create more content and still get that work done, I'm going to go ahead and do a video on the work that I'm doing. Let's take a closer look. So I don't talk about it a whole lot. I've mentioned it maybe a couple of times, but the side work that I do is a lot of automation projects. What I mean by that is I basically build the tooling for robots. Now, I've mentioned that before, but sometimes if you're not in the field, that can be a little bit challenging to understand. So, to make it a little bit easier, we're going to go ahead and take a closer look at some of these models. Now, the model that I'm going to show you is intentionally fairly bare. It is a concept that I'm still developing for the customer so that they can basically put their stamp of approval on it. Whenever you're doing any type of automation cell that involves robots, conveyors, part handling, you always need to make sure that you get customer sign-off and approval on the method that you're picking up the part, what robot you're using. A lot of times there's specs. With the part, sometimes you can't pick it up because you don't want to damage it, which is actually why we're doing this project. Now, I'm not going to name companies. I'm not even going to show you guys a part that I'm handling because a lot of times that kind of material is proprietary and cannot be released to the public. But with the robot being in total concept right now, there's no issue with that. So we're going to jump into the model now, and maybe this will make a little bit more sense to you guys. So here's the robot that we're working with. Right now, I've just got a Fanuc LR Mate. It's a 200i. I've got an area scanner back here in the back and a conveyor. Now, when you guys look at this, you'll notice that the stand is really basic. There's nothing to it. In fact, I didn't even hollow out the tubing to show you guys that it is tubing. It looks like solid stock. But there are a couple of things that are pretty well defined. This fence, I'm quite positive will be there, so I went ahead and mocked that in. There's no fasteners or anything. This conveyor, I just downloaded a model of what I've used in the past, and the legs are sticking out. You know, that kind of stuff is okay for a concept. It doesn't have to be perfectly defined. The Keyence area scanner that I've got here, there isn't anything to it. It's not even bolted down. It isn't interfering or anything, but it's not bolted down. Now this robot plate, that does have some detail. It's got the locators in it, and it's got other bolts in it. Now, a lot of you guys that have done this work are going to look at that and say, what the heck, why are you bolting that down to a plate and then bolting that down to the weldment? Well, I've got reasons for that. The big reason is because the holes in this subplate are oversized. That way, these can basically be hand drilled. So that way, I can build this in my garage and it still looks like a professional system that is done well. And that's a big thing when you're doing this kind of design work. Now, I've been kind of playing with different grippers here, and I really like these for picking up on a cylinder. So I've got the open and the closed models in there with a 5-degree change for the closed. Not going to show you guys the gripper fingers. We're just going to leave that off. Weird little plate there, nothing big or anything. So this is basically a rough concept. Now, the reason why this is still a concept and I haven't gone forward with it is because a lot of times the customer is like, well, I don't really like how you're touching the part there. Maybe they don't want to go with that particular robot. This particular customer doesn't actually have a ton of these smaller robots. So, you know, these are all things that you typically try and iron out in the beginning stages by developing a concept like this. Now, I have very little time in this, maybe 2 hours, which again seems like it might be a lot, but that's, you know, finding a conveyor, downloading the right robots, doing a little bit of research, finding grippers, which I've got the paperwork all printed out here, actually covering the parts that I've got on my desk, because again, can't show that kind of stuff. So there are lots of reasons why you just put a little bit of time into it at the start. So this is the kind of thing that I do on the side. They're not big cells for the most part. The last one was pretty sizable, but it went off beautifully. My part of it has worked awesome. I'm really proud of that. I can't put pictures up because of all the proprietary stuff in it, but regardless, this is what I'm building on the side, and this was ultimately why I started the YouTube channel. I'm really hoping to be able to start machining my own grippers. I'm really hoping to be able to machine my own subplates and that kind of thing. I won't be able to get a machine big enough to machine a full weldment like that, but little brackets are why I built the plasma. All of this stuff is what I am working towards in the future. So if you guys have any questions about this kind of thing, make sure that you leave me a comment down below. I would love to hear what kind of questions you have. Have you guys worked with the robot before? Just throw that down in the comments. If you enjoyed the video or are interested in knowing more about this kind of stuff, since this is the first video I've done, go ahead and leave me a like. And again, make sure you comment, say, I definitely want to see more on this stuff, and go ahead and subscribe, because I'm probably going to be doing more of this stuff. I've got some sensor brackets I'm going to be making for this particular cell, so just make sure that you guys subscribe, and I will see you guys next time on Engineering Awesome.